Today what we're going to talk about is the slope of a line. So when we talk about slope in general in mathematics, or if I'm doing architecture and I want to figure out the slope of a roof, slope is always rise over run. Would you guys all agree with that? I'm sure you guys have all seen that at some point in time, figured out some slopes. So what does rise mean? That's a vertical distance, correct? So if we talk about where on our imaginary cube here that we can see vertical distances, say that again?
The y-axis.
The y-axis? And which planes do we see the y-axis? We don't see it in the horizontal, right? Well, let's take that back. It wouldn't be the y-axis, it'd be the z-axis, because x and y is on the horizontal. So it'd be our z-axis. So our z-axis we would see in any elevation. So the front, the left profile, the right profile, the back, those would all be elevations. Agreed?
Yep.
So those are some of the views where we can find our slope. But we also have other elevations. So remember that when we have a view, an auxiliary view that's hinged off of a horizontal, this is an elevation too, right? It's an auxiliary elevation view, because when I fold it up this way, here's the top, and these are both vertical surfaces. So in order to find the slope, we know it has to be an elevation, but there's a little bit more to it than that. If I have a situation like so, here's my front, here's my profile, here's my front, here's my horizontal. I'm going to ask you guys a trick question. Can I measure the slope of that line? Remember, it's a trick question.
It won't be true.
Maybe. That's a good point. So not only does it have to be an elevation, it needs to be a true length. So just given what I have here,
You could.
I don't know. I really don't know. Because I don't know, is A closer to my eye than B? So my top view, if my top view looks like this,
That one.
now can I measure my slope in the front view?
I don't know. Looks like it's a couple degrees off.
Okay, aside from my scribbling.
I can't be for sure.
All right, I got you. So the definition then is you've got to have a true length line in an elevation. That's the only way that you can measure the slope. So if my top view had looked instead like this, then I can't measure the slope here, right? Because this isn't true length. So I need to make a true length elevation. So should I hinge off of here, or should I hinge off of here? Which view should I hinge off of to find an elevation? I should hinge off of the horizontal. Because remember, if I hinge off of here, we call it an auxiliary incline. And if I did this, and I created a line, and I figured out, whatever it might look, and I measured its slope, what that's actually telling me is how far back it's sloping away from the front plane. So here's the front plane. It would tell me how far back it slopes from the front plane. I don't care about that. What I want to know is how far down from the horizontal plane does it slope. So it has to be an auxiliary elevation view. So if you've got true length in the front of the profile, measure it there. If you don't, then you need to create an auxiliary elevation view by hinging off of a horizontal plane, and then of course your resulting view would be a true length, and then we can measure it. Let's switch back here. So again, on the slides, just recapping all of that. Again, second bullet here, it's got to be an elevation. It has to have true length. What is an elevation? Front, profile, any auxiliary view hinged to the horizontal plane. So in terms of the inclination or the slope, if you will, we're going to represent it three different ways. So in my exercises, if you're asked to calculate the slope, that's just a decimal. So rise over run displayed as a decimal. If you're asked for the slope angle, then we want it obviously as an angle. And if you are asked for a percent grade, then basically we're going to take that decimal and then show it as a percent. So we'll look more at that as we go through here. And then we got to figure out, is it positive or is it negative? So that goes back to the lettering of the lines. So we go in alphabetical order. That tells us which direction it's going. So obviously if it's going up, it's positive. If it's going down, it's negative. And then the slope angle is just the acute angle between the horizontal plane, if you will, and then the true length line. We'll look at that in action here in just a second. So here's one. First of all, I can measure the slope in the front view, because in the horizontal plane this is parallel to the front, therefore this is true length. So I can go ahead and measure the angle. Now, when you're doing this, you don't actually have to draw in a line and find the angle. You can just dimension it right to the horizontal hinge here. It's the same thing. But then you got to determine, is it positive or negative? So as I go from F to G, I'm going up towards the horizontal plane, so it's positive. And the way I worded that is important. I didn't just say it's going up. I said it's going up towards the horizontal plane. Because when we get into auxiliary views in a little bit, it's a little confusing which way's up and which way's down. So we'll talk about that in just a second.
50 degrees then, if you did up the horizontal?
It would still be 40 because the alternating interior angles. It would be 50 from vertical, but yeah, it'd just be 40 from here. Yep. So here's another example. Similar line. I can measure the slope because this is parallel to the front, so this is true length. And again, don't need to draw this line. You can just measure it from the horizontal plane. The measurement would be 28 degrees. Then I need to determine, is it positive or negative? As I go from C to D, I'm going down away from the horizontal plane, so it's negative. Now, on the exercises, on the assignments, I'll ask you to either use the text tool or something like that out to the side to write the slope. I don't want to see just the angle, because when you do the angle, it's just going to say 28 degrees. I want to see that you actually put in negative 28 degrees. On this one would just say 40, and you might say, okay, it's a positive 40, so I don't need to do anything else. No, I want to see that you've thought about it. So with the text tool out to the side, I want to see either 40 degrees or negative 40 degrees. That make sense? Is this one correct? No? Why not? I don't have a true length. Exactly. So this is kind of like when we talked about bearing. Remember, bearing is always in the horizontal plane, but sometimes we see an angle line and we want to start measuring. So we want to make sure that it's a true length before we start measuring. So since it's not a true length, I would actually have to construct a true length in order to find the angle. So should I hinge off of the front plane or the horizontal plane? Horizontal, because that will give me a true length elevation. So it's an oblique line. Again, can't measure it in either view, so I'm going to have to set up a true length line. So once more, I set up the hinge parallel to this line, do all of my projecting to get a true length line here. And then here's what's important about this angle here, this 27 degrees. So first of all, notice that it's not measured from just a horizontal line here. Because what does horizontal mean? Horizontal is this top plane, and this is the hinge for that top plane. So you should be measuring from the hinge, not from just a horizontal line. Does that make sense? Because again, in this view, this means horizontal, not side to side. So then I would just measure this angle. And then here's where it can get kind of confusing. C to D goes up on my screen, right? But what is its relationship to the horizontal plane? As it goes from C to D, it goes down away from the horizontal plane. Therefore, it's negative. Exactly. Now, when you're considering positive versus negative, you can always just look at your front view. I can't measure the slope in the front view, but I can tell if it's positive or negative. C to D is going down away from the horizontal. So negative 27 then would be this one. If we're going to do the slope as a decimal, then we have to be able to measure the rise and the run. And I'll show you more on exactly functionally how to do that in AutoCAD. But what's important is the rise or the fall versus the run. What does that mean in this view? It's not horizontal and vertical to my screen. Horizontal is parallel to the horizontal plane. Vertical is perpendicular to the horizontal plane. So I'll need to lay this out to measure the dimensions there. And I'll show you in just a few minutes how to do that in AutoCAD. So let's take a look at AutoCAD. You guys will remember the other day we did a bearing angle practice and we saved it to your class folder. So if you guys will open that one back up. If you didn't do it or you didn't save it, just go to new and the templates folder and the additional files and just do a new one from there again. But assuming that everybody saved it to your folder, we'll go back into bearing angle practice. So in this first situation, I'm already going to break a rule. So I told you that you can only figure out slope if you have an elevation that shows true length. I don't have an elevation that shows true length. I have a horizontal plane that shows true length. If I were to create, and don't do this with me, but I'll just show you here real quick. If I were to create an elevation that showed true length, it's really not going to tell me a whole lot. So I'll project A and B across, go back 2 views for my offset, A and B are the same. So then that's going to give me line A, B here. So I already have the true length, so this is basically just a copy of it. But I don't really need to construct that view to figure out that this line doesn't go up or down, right? It's a horizontal line. So what slope does a horizontal line have? 0. So it's a 0 degree slope. But we're doing decimals, so the first one, slope as an angle, no, I guess we're doing angles first, I'm sorry. So slope as an angle is 0 degrees. 0, remember you can do %, %d, or you can go up and hit the symbol. And do make sure you get those degree signs in there. So the slope as a decimal would just be 0. And the slope as a percent would be 0%. Again, make sure you get your signs in there. So that's really the one exception where you don't have to construct, actually one of 2 situations. A vertical line will be another. We'll see in just a little bit. Although the vertical would be true length in the front. So this is really just the one situation where you don't really need an elevation with a true length. So if we take a look at CD, first of all, can I measure the slope in this view? Yep, I got a true length elevation. So for the angle, we can just use the dimension drop down here and choose an angular dimension. And pick line CD and pick the hinge. And like I said the other day, if I give you 2 decimal places, then I expect 2 decimal places in your answer. So I've got a 29.36 degrees. Is this going to be positive or negative? So as I go from C to D, I'm going up towards horizontal, so it's positive. So 29.36% D. And then I'll just delete that. Now the slope as a decimal, let me show you a couple things about dimensioning tools. AutoCAD 2016 has a brand new dimension tool in it. This one right here, which is a kind of a quick dimension tool. And it's supposed to be a smart dimension tool that will change depending on what you click on. So if I just clicked on this line, it'll either give me an aligned dimension, or if I move my mouse down a certain way, it'll give me a horizontal dimension, and if I move it to the side a certain way, it'll give me a vertical dimension. So this is pretty cool, but I will show you that if you aren't liking that, or if you have some trouble getting the exact dimension that you want, then you could use the dimension drop down here, and a linear is going to be one that just gives you horizontal or vertical. I didn't snap to the right point there, so let me do that again. And then when it comes time to want an aligned dimension, then you can use the drop down and use the aligned, and then that will measure the length of the line. So you can use either method, whichever you like. I'll probably just stick to the quick dimension one. So I've got a run of 32 and a rise of 18. So 18 divided by 32. 18 divided by 32. 0.5625. Positive or negative?
Uh,
Positive. So C to D is going up towards horizontal. So our slope then would be 0.5625.
We don't need to keep the dimensions on there.
You don't, no. And I don't care if you do. I'm not going to count off if you do. But you don't need to keep them on there. So then to show slope as a percentage, we just need to multiply by 100 and then put a percent sign behind it. So multiplying by 100 also means moving the decimal place 2 to the right. So that means I would have a 56.25% grade.
What is 56, that number? This is the right way to run, right?
Say that again, I'm sorry, Tommy?
The 56, 25, so I was drawing the dimensions.
That's right, so this was the rise divided by the run. 18 divided by 32 gives you 0.5625.
All right.
And then times 100 gives you 56.25%. So as we take a look at the next one, it's actually the same thing, but I just swapped the letters.
switch all the signs.
Exactly. So same values, they're just all going to be negative now, right? Because C to D is going down away from the horizontal plane. So negative 29.360 degrees. Negative 0.5625 and negative 56.25%. So as we look at E to F, what would my slope be for this one?
0.
0. So just like the first situation we had, they're all 0, but I do expect to see symbols even on zeros. So 0 degrees, 0 as a decimal, 0% as a grade. So as we look at GH here, can I measure slope in the front? It's not a true length line, is it? Because this is not parallel to that, so it's not a true length. So therefore we need to construct a true length, and we could do that either by hinging off of the horizontal, or since this is parallel to the profile plane, if we constructed the profile plane, that would also be a true length. So I'm going to draw in a hinge line here. F to P. Then I'll draw my rays. By the way, while I'm doing this particular one, there were several people on the last assignment that did this very thing, but then got your lines backwards when you came out to this view. So if you decide to do more than one point at a time, you really got to try to keep track of which point is which. So I'm going to offset into the current layer. So again, I always just talk to myself and say H is the close one, and then G is the far one. So H is the close one, G is the far one. So this would be my true length line here. So it's true length and it's an elevation, so I can measure its slope. So to measure its slope, we're going to need rise and run. So I'll use my dimension tool, and looks like a run of 16 and a rise of 20. Divided by 16 is 1.25. Is this going to be a positive or negative slope? I did just jump over the angle. I'll come back to the angle since I already started this. Positive or negative? Does it go from G to H? Am I going up towards the horizontal plane or down away from the horizontal plane? Negative? So I'm going down away from it. So negative 1.25 would be my slope. And then as a percentage, that would be negative 125%. So then I'll come back for my angle since I skipped over that. Angular dimension looks like 51.34 degrees. Also negative. So let's take a look at line LM. What kind of a line is this?
Vertical.
Vertical line. So if I were to take the height of 18 and divide it by the run of 0, in mathematics that's an undefined number. Thank you, Michael. So vertical is an undefined slope. So that's the answer for the slope on each of those.
Thanks for the tip.
So just make sure you keep clear the difference between a 0 slope, which is a horizontal line, and undefined, which is a vertical line. So now we come to the last one, and just to clean up my screen a little bit, I'm going to get rid of my dimension that I used for bearings the other day. So the first question is, can I measure the slope in the front view? Is it true length? Nope, so I'm going to have to create an auxiliary view, and for it to be an elevation, I want to hinge off of the horizontal. So I'll lay this out. Directly parallel. And then draw my rays. Now, if you get ahead of me, after you draw this true length line, don't erase your construction lines. I'll tell you why in just a minute. So I'll project my O and P over, come back and get my offsets. P is the closer one. O is the further one. So therefore, there's my true length line. Now you're still asked to label the TL. You're still going to be finding the PVs on your assignments, so you'll be asked to label those as well. And like I said, just leave those construction lines for now. So if I want to find the angle, the slope angle, remember you're not measuring from a line that is horizontal on your screen. So don't draw that line and measure this angle, that's incorrect. You're measuring from the horizontal plane. So an angular dimension from the true length line to the horizontal hinge here gives me an angle of 22.58 degrees. Are we positive or negative? Positive. So remember, just because it's O down to P on my screen, what's important is O to P is going up towards the horizontal. And you can always look at the front to confirm. O to P is going up towards the horizontal. So 22.58 degrees is my slope angle. So now, for figuring out my rise over my run, here's why I don't want you to erase your construction lines. I'll show you up on my screen. I erase my construction lines, And then I go to measure my rise over my run. Is this my rise and my run? It's not, right? Because run is perpendicular to the horizontal plane. Or excuse me, did I say run? Rise is perpendicular to the horizontal plane. Run is parallel to it. So just like down here in the front view. Run is parallel to the plane. Rise is perpendicular to it. So if you leave your construction lines, you have some really nice points that you can click on to dimension between. So I can dimension from this point to this point, and that's going to be my run. And I can dimension from this point to that point, and that's going to be my rise or my fall. So I would wait to delete those construction lines until after you've got your slope figured out. So it looks like I've got a rise of 15 divided by a run of 36.07. And typically I'll have you do 4 decimal places on these because I want your percent grade to be in 2 decimal places. So 0.4159 would be my slope as a decimal. And then my slope as a percent would be 41.59%. And then of course you can go through and erase your construction lines. So the number one problem I see on this one is people actually taking the horizontal and vertical dimensions as they are on your screen, just like I showed you a while ago. All right, so you can, of course, save that. That might help you on the exam when you're figuring out slopes, that sort of thing. So the assignments for today, we're going to do 2 of them, lines 7 and 8. So let me pull those up and talk about them for just a second. All right, so lines 7. As we look at the instructions here, you are to, first of all, determine and label the true length. I don't ask for the point view on this one. Determine the true length and the slope angle for these 2 lines. So again, just use your text tool, multi-line text tool, and whatever you think the angle is. And I'm not saying this is the angle, but I'm just giving you an example. Out to the side, type in what you believe the slope angle is.
You said like 6 and 7?
Lines 7 and 8. So then the next 2, I ask for the slope. And again, if you're asked for the slope, that's rise over run as a decimal. And then the last 2 here, the slope is a grade. As you can see, they're both oblique lines, so you're going to be constructing some auxiliary elevation views to find your slope on that one. On those 2, I should say. So that's lines 7 with lines 8. So we got 3 different examples here. I'm bringing the bearing back in on this one, so you got to remember to keep those straight. Remember the bearing is always in the horizontal plane. Slope angle is always in a true length elevation. So you're also asked to find the point view on this. So find and label the true length, the point view, and then for the bearing and the inclination or the slope, just again, double click on the text that I've got there already for you, and then you can type in your answer next to it. So do note this one you're going to do the slope angle. This one, grade as a percentage, and then this one, slope as a decimal, and then finally classify each one. Frontal, horizontal, profile, vertical, oblique. And that'll be it for today, just these 2. So as always, let me know if you run into any questions.